Hello everyone. So today I'm going to speak more about inputs and outputs. So if you haven't watched my last video about what a PLC is, go check it out before you watch this so you have an idea of how inputs and outputs actually work. So I want to get into more details of what an input is and outputs, some examples, and how they're used in industrial settings. So generally an input is something that is going to send a signal to the PLC, which then, depending how you program it, will send an output, a signal to output, which will make something activate or work. So some examples of inputs are like sensors, switches, push buttons, and just remember that inputs or output, they usually start with a state. Um, so what does that mean? It means what state is it on when nothing's touching it, when we call it a normal state. uh, when it's not being triggered, activated, or anything, what is it set to? And most of the time it's either on or off, 0 or 1. And it's important to know these states because the PLC will consider those normal states, and when those state changes, the program will activate the output do based on the state that changes. Okay, so give you a little example. One of them, a common sensor we have in the industrial setting are photoelectric sensors. This means it has a, pretend this is like a sensor bar. We have a transmitter and a receiver. Okay, what you don't see with these sensors is an invisible laser that goes across. So in its normal state, when nothing is touching it, it is currently on. This state is on right now. And the only time it goes off is when you break that sensor. And then it will go off. Okay? But in its normal state, meaning nothing's touching it, nothing's triggering it, nothing's breaking it, the PLC is reading that it is currently on. Okay? And it's not going to do anything. But once you break it, once again, now it goes off. The PLC takes that information, that data, and it's going to send a signal out to an output now that it's off. Because it changes state, the PLC was programmed to check for the change of state, and with that information does what it needs to do according to the program. And this photoelectric sensor, a good example would be like a garage door. You have a garage door, it has a through beam that goes from one side to the other. When the garage is coming down, for safety, if something walks past that garage door through that through beam, it's going to cut off the electricity to that garage, and the garage will not go down. And it will basically stop the garage from continuing what it was going to do to prevent any injuries to somebody that's walking under the garage. And usually a through beam or a photoelectric sensor are used for safety in the warehouse, in the factory. For example, you have a space or a cell. Um, let's say you have a cell right here. Okay, all your equipment is here, equipment's here, equipment's here, and they'll have, we'll put a photoelectric sensor right here, a through beam sensor right at this space right here where the door is at. Okay, and it has an visible laser going through. This is saying that nobody's in the cell right now. The equipment is allowed to run. Okay, now let's say somebody is wandering around and they walks walks through this door when they're not supposed to. They're supposed to stay out of the cell because the equipment is running. It's a lot of heavy machinery and somebody could get injured. Let's say somebody's wandering around, has their looking at their phone, they're not paying attention, and they walk into that cell. The minute they break that through beam, the cell will stop, because in the PLC it has been programmed that if anybody breaks that through beam, the cell has to immediately stop. And this is for safety, so that they don't get injured accidentally walking into a cell when everything's running, and they could get really hurt. So a lot of the times we use photoelectric sensors for safety, and these are considered inputs because it's sending data, it's sending a signal, okay, sending a signal to the PLC, and the PLC is receiving that signal. Okay, and depending on how you program it, the PLC will send the signal to the output, and the output is receiving that signal. So it's basically flip-flop, it's reverse. So that's one example of an input. Okay, photoelectric sensor, mainly used for safety because it's normally on. If you break it, it will turn off. So that is a photoelectric sensor. Okay. The next one I want to talk about is I don't know the technical term, but it's like a magnetic field sensor. Um, so you'll have a sensor. Okay, this is the wire, and this sensor in it has a magnetic field. Same concept. Depending on what state is on, for all our examples, we're gonna say it's always on the off state from now on, because that's more intuitive. When something is not being touched, it should be off, right? So let's say it's in its off state, and then these sensor, they're called proximity sensor because they have a proximity magnetic field around it. So when something passes it, it changes state. So for example, like right now, currently it is off, and you want to detect when a pallet gets to that position. So the pallet comes down, it breaks it basically triggers it, and depending on what you program in a PLC for that state change, what you want to do with it, it will send the output out. So in this example, we'll say that when a pallet gets to this position, we want the conveyor to stop. So currently it is off. The conveyor is running. Nothing's happening. Boom! It breaks the proximity, the magnetic field. Once it breaks that magnetic field, the sensor changes states, and that state sends that signal to the PLC. Now the PLC reads it, sends the output telling the conveyor to stop, and now this pallet will stop right here where it is. So that's another form of input, a magnetic field. When it reaches the proximity around there, it will change states. Okay, so they're all the same concept. It's in its normal state is either on or off, and when it breaks that barrier or breaks that proximity of that sensor, it will change the state. And when the state changes, depending on how you write the PLC, it will send a signal to the output to make something else work or something turns on or off. Okay. And the last one, another example I want to give you would be a mechanical input. So far we had a more like a magnetic field or electrical sensor. This one's more of a mechanical sensor or a mechanical switch. We usually call them switch. Okay. Let's say currently we have something called a limit switch, very popular. Okay. It's usually like this. It's like a bridge, however you want to do it. Currently it's in its off state. As you can see, there's no continuity. This is currently off. And same concept. Let's say we have a pallet and we want to use a mechanical switch. Pallet comes, it physically hit this lever right here. Okay, that lever, when it hits that lever, it moves it. It will move down and create continuity, create contact with the other side to complete a circuit. When it completes a circuit, it turns on. Right? So it was currently off when in its normal state when nothing's touching it. And then the pallet comes, same concept. When the pallet gets there, we want it to physically stop the conveyor. Runs down, runs down, runs down, boom. It hits the lever moves down. Now it creates contact with the other side, which turns on. Once this turns on, the PLC reads it as on, and it will send a signal to an output to make something else work. So that would be a mechanical input. And there are many different inputs, different examples. But the main thing I want to, make a point at is the input is going to send a signal to the PLC, or the PLC is going to receive a signal from the input, either or. And usually it will start out at a normal state, either it's on or off. And when that state changes, the PLC reads it and it will gather that information, and depending on how you program it, it'll send an output signal to do something else. Okay? So that is the input. Now I want to talk a little bit more about an output. What is output in an industrial setting? We have a motor. Okay? Usually a motor. Everybody knows what a motor is. It's just something that turns. It circulates, just like you're in your car. You have a motor. It turns, and usually this will run a conveyor. Draw that right there. Okay. Another output would be a light. We'll just draw a light bulb just for easy, just so you can see it. A light. Okay. Or sometimes or a cylinder. A cylinder will move in and out, or yeah, it goes out, it goes in. Actuator, whatever you want to call it. But pretty much the input will change states based on what triggers it. And the output changes state based on what the PLC tells it to. So the input is sending the signal to the PLC, and the output is just waiting for the PLC to tell it what to do. Okay? So just remember The output is something that's gonna work. It's gonna be the result of what the input sends it. So let me put a full example together so you understand. Okay, we have a push button that is an input. This one, the user actually has to push the button down, right? And we have a conveyor. Let's say we have a conveyor. Okay, very common in the warehouse, these conveyors. Okay, and then that conveyor, well, it has to have something to move it, right? We'll just put a little motor right here. Okay, and usually the push button is going to be wired to the inputs, and the output is going to be wired to the motor. You can see right there is a full circuit, as you can see, right? And currently in its normal state, that means nobody's touching anything. It's being left alone. Nobody's activating anything. What is its normal state right now? Currently, it is off. This push button is off. Okay? And because you programmed the PLC to say turn on the conveyor when this push button is pushed, but since it's off, this motor is also off right now because it's programmed like that. But besides the point, we're just trying to kind of elaborate on what the input does and output does. Okay? So right now in its normal state, everything is off. So let's say your manager tells you to turn on the conveyor. So what do? You go to this push button right here and you push it down. Since you push this button down, now this push button is on. Now that it's on, this push button is on, the PLC reads the signal. And the state has changed, so it reads, oh, now that it's on, based on what I was programmed to do, I have to send a signal out to tell the motor to turn on. So once this button is pushed down, the PLC receives that on signal. Then after that, the PLC will send an output signal, which will turn the motor on, which turns on the conveyor. Now the conveyor is on. Very simple, very basic. Of course, when you get into more components and devices, it's going to be a little bit more complicated, and it's not as simple as just one wire in, one wire out. You're going to be dealing with multiple wires with different devices to help this whole operation work. But at the very core, you're going to have an input that is going to change, have a normal state, is in its normal state. Then it changes state, and based on that change of state, the PLC will send an output out to make something turn on, off, make it work, activate, whatever you want to call it, and it completes a circuit, as you can see. Okay? Sometimes it could be the opposite, like that through beam. What if I don't have nobody there to keep the conveyor on, to push the button up and down? To push the button, right? Well, this is where the through beam could work. This is not applicable usually, but it's just an example to show you that how to keep it always on, right? This through beam is always on. Let's say that conveyor is in a cell. Since you program it for the conveyor to turn on when the input is on, the conveyor is always running for however long you want it to run until somebody walks through that beam. Now it is off, which turns the motor off, and then turns the conveyor off. Now the conveyor is completely off because somebody walked into the cell. But as you can see, you can flip-flop it. You know, it could be in its normal state, could be on, and the normal state could be off, depending how you configure it, what is your application, and how you want the PLC to program that. So that is a quick review of the inputs and outputs. Of course, there are many different inputs devices and many output devices, but these are some common ones. Some will be magnetic field, some will be mechanical, photoelectric. They have different uses for different applications, and just know that the overall concept you want to get out of this is when the equipment and when the cell is set up, it has a normal state. The devices has a certain normal state. The output motors also have a certain normal state, and depending on how you program it, when that state changes, what do you want to do with that data? What do you want to do with that signal? Are you going to turn something on? You're going to turn something off. You know, and that's what inputs and output. That's how they work together. Input sends signals to the PLC. The output waits for a signal from the PLC, and that's how everything works together. Once again, thank you for watching my video. If you have any questions, please leave them below. If you have any information you want to provide or add to this, please leave them for other people to learn. And until next time, thank you very much. Bye bye.